Okay, weather fronts. Here comes a slideshow. Now, this is the title of the assignment. Title your paper, Weather Fronts. It's assignment number 29. And here we go. First of all, you need to know what an air mass is. This has to do with air masses, and an air mass is a region of air. Now, generally speaking, when you were seeing that satellite view, that's where the clear areas are, right? And it's at the boundaries between the air masses that you have the weather systems. But the air masses can come with four basic situations. One, they could be warm or cold, or they could be wet or dry. Now, if they're going to be off the ocean, it's called a maritime air mass. I'm not going to make you write that down, but if it's coming off the ocean, it's going to be wet, okay? And that's what we generally will get, which is one reason why it rains so much in the Northwest. Now, dry air mass is going to be coming off of a continent. They call it a continental air mass, and so that wouldn't have much moisture in it. So air masses can have a lot of moisture, a lot of humidity, or they can have very little humidity. They can also vary in temperature because they could be warm or they could be cold. Now, generally, if they're coming from the south, they're called tropical air masses, and they're going to be warm. Whereas if they're coming from the north, generally speaking, they're going to be cold air masses. It's going to be cold. So they can vary in temperature, and they can vary in how much humidity they have in them, okay? So the air mass then, if you have these air masses that collide in with each other, like, do you remember what convection is? Hot air, what? Because it what? What? Oh, that's right. Hot air rises because it's less dense. Well, what will happen when these air masses meet? You might think, oh, a warm one meets a cold one, it's going to kind of just cool it down. Well, that's not what happens. They actually don't meet. Here, take a look at this video, a little demonstration of what happens when air masses collide. Okay, so what I'm going to do here is demonstrate something about what happens when you have a warm air mass in the atmosphere and a cold air mass in the atmosphere. When they clash, what are they going to do? Here I have two things of water. This one's cold. Well, it's actually just cool water right out of the tap. It's not particularly cold. And this one is warm. Again, it's just warm water out of the tap. Nothing particular, it's not boiling hot or anything. Let's add a couple of drops of red food coloring to that one. And for the cold one, let's add a couple of drops of blue so you can tell the difference. By the way, I think that watching food coloring move through water is just beautiful. There's a science called fluid dynamics, which honestly, the mathematics of fluid dynamics is way past my skill level of understanding the mathematics of it. But it's pretty beautiful. So let's just go ahead and stir this up a little bit. So we got some blue cooler water, right, and some red cooler water. All right, now here's what we're going to do. We're going to pour them together. Well, you think, well, it's blue and red, it's going to make purple. Well, let's see what happens when they meet, when they clash. And so I'm going to set it up here where there's a little aquarium. Okay, and this is where I'm going to pour the two waters and mix them together. But I'm going to have them be divided at first. I'm going to just put this little divider in here so you see what's going on. Let's try it this way. There we go. And so it's a little loose. There might be a little bit of leaking. You know, it's just a piece of poster board. And now I'm going to pour the two waters in together. And the trick here is to try to pour them at the same rate. If you pour one of them faster than the other, one's going to leak into the other side. If I can pour them at exactly the same speed, the warm on this side and the cool on that side, then they should stay separated. So far, so good. Okay, a little bit of leaking over on one side or the other. Okay, that's good enough. So we got red with the warm and blue with the cold. Now, just so you can see it better, I'm just going to put a piece of paper behind it. Does that help? Yeah, a little bit. About like that. Oh, that helps. I know. Let's put this behind it so you can see better. Now, what do you think is going to happen when I pull this divider out? You think it'll just turn purple? Well, let me see. Hot air is less dense than cold air. So which one do you think is going to rise or go up? What happens when two air masses meet but do not mix? This is what happens in the atmosphere, and it's what makes weather systems happen, by the way. When cold meets warm, watch what happens. Oh, the warm went on top. Oh, now they're sloshing back and forth a little bit. But look, instead of just turning purple and mixing, they didn't mix. The cold water's on the bottom, and that pushed the warm water to the top. So the hot air, it rises because it's less dense. Well, a hot air mass, when it clashes with a cold air mass, is going to be pushed upwards. And so this is what happens. Now, what's cool about this, I don't want to leave the, can I, I don't want to leave this video going for the sake of memory for too long. But if you let this sit here for 15 minutes, it'll still be separated. I mean, it takes about a half an hour. And, you know, if we have a chance during class, maybe I can try this demo live. At any rate, this is what happens when air masses clash, hot and cold. The warm gets pushed up over the cold. And that when hot air rises, because it's less dense, well, that also will reach the dew point, and that'll make precipitation happen. That'll make it rain, make it snow. That's why we get weather systems, at the meeting of the boundaries between hot and cold air masses. All right. Okay, in that demonstration, you saw that when air masses collide, they don't mix. What they do is the hot one, the warmer one gets pushed upward by the colder one, right? And when it rises, it's going to cause the humidity in the air to condense, to become droplets, to become, when those droplets come together to form raindrops or snowflakes, you get precipitation. Okay, now what this video here is 1 week's worth of the movement of the atmosphere across the United States. And with the movement of the atmosphere, of course, it's moving the weather systems with it. And notice how you have areas of clear sky alternated by these patterns of cloudy sky and sometimes stormy sky. And so what I want to get into in today's lesson is, why do you have that pattern? You have these certain several days where it's clear sky, and then a rain system comes in and it starts raining for a few days. Like here's a really nice storm system coming through here through the southwest. Here it's clear sky, but then, oh, now it's going to start to get all cloudy and stuff. Well, what's happening in the atmosphere to make these systems happen? These systems are called fronts. These are the boundaries between different air masses, okay? What are they called? Fronts. Say it now. It's a front. Okay, so what happens then at the boundary between two air masses meet? The cold air pushes the warm air upward, and that causes those cloud systems, the weather systems, the front.